Okay, we're looking at mixed exercise 6 from the first year core textbook, and we're looking at question 22. So we've got 3 points in the circumference of a circle, and we're told that we've got a right angle. So that is going to be important. They do draw quite a lot on your circle theorems on this, because if you've got 3 points on a circle and we've got a right angle at A, then that must mean, so let's move it up a little bit. So if we've got a right angle at A, it must mean that BC are a diameter. Okay, so that's one of the circle theorems that you covered at GCSE. So we've been quite subtle there. So you've got to be quite on the ball, but they're not going to tell you that for no reason. So there's going to be some relevance. Why has it turned my C into a circle? There's going to be some relevance to telling us that that's a right angle. Okay, so, but we might not, I actually don't think we need to use that until part B, because what are we going to do to find Q? So, sorry, oh yeah, Q. No, actually, I think I am going to use that, because I think the easiest way to find Q, so I know that that's 1Q, and I know that B is -6, 0. So what's the best way to go? Well, I can find AB, and I know that the gradient of AB is going to be perpendicular to the gradient of AC. So I could use that, and then I could also, just trying to make sure I'm not overcomplicating it, I can find the length AB, and then I can use Pythagoras. Yes, so I think I can just go straight to Pythagoras. So obviously I've got a right angled triangle here. Okay, so if I just label them up as A, B, actually I'll do it. So I'll stick to the way they've labelled the vertices. So that would be side A, that would be side B, and that would be side C. So A squared would be B squared plus C squared. So that's not normally how we would quote Pythagoras, but A is the hypotenuse in our triangle. Okay, so I can get C. C is just the distance between A and B. So C is the square root of minus, hang on. Right, A is something in there. That does not make sense, is it? They're the same coordinate. A was -3, -2, right. It is -3, -2. Okay, so I can find the distance AB. So I'm doing -6 minus -3 all squared plus 0 minus -2 all squared. So the distance between 2 points should be quite straightforward by now. So that's going to be -3 all squared plus 2 all squared. So that's going to be root 13. Okay, right, so I can't get the other two side lengths, but I can define them though in terms of lowercase q. So this side here, so A is going to be the square root of 1 minus -6 all squared plus q minus 0 all squared. So A is going to be the square root of 7 squared plus q squared. And obviously, be ever so careful, you can't square root those two terms separately. And then B is going to be, right, let's just get that away for now. Okay, so B is going to be the square root of 1 minus -6. No, excuse me, ignore me, I'm looking at the wrong one. Right. B is going to be 1 minus -3 all squared plus q minus -2 all squared. So B is going to be square root of 4 squared plus q plus 2. So I'm probably going to have to square those brackets out, but I'll leave that for now. Okay, so then thinking about Pythagoras, so I've got I want me to do that. I have got, those are my 3 side lengths of my right angle triangle. So let's get a bit more onto the screen. Okay, so Pythagoras says that the 2 shorter edges squared, so obviously squaring is just going to get rid of these square roots, but I'll write it like this to just be really clear. So this side squared plus this side squared. So you could just basically just write this without the square roots rather than square roots and then squares. So that squared plus that squared equals that squared. So root 49 plus q squared. So then, if I sort of cancel all those square roots, then squared, it suddenly looks a lot nicer. Okay, so basically a quadratic in Q, so we can solve that. So 13 plus the 16, let's square out those brackets. Okay, yeah, and in fact it was quadratic, but it just gets better and better because I can minus q squared from each side, so I don't even need to solve the quadratic. I can just say that, so I'll keep the 4q on the left-hand side, and on the right-hand side, I've got 49 minus 29 minus 4. So 4q is 16, so q is 4. Is that what I wanted? Yep, so find the value of q. So then find the equation of the circle, which I'm going to learn from past mistakes and just check that is the right value of q. Yep, we're good. Okay. So now we want the full equation of the circle. Well, so I'm going to sketch it out again. Right. Well, we haven't actually used what I said at the start, which is that BC is going to be a diameter. So BC is the diameter, and we've just figured out for C that Q is 4, so that means C is 1, 4. So that's all we need. Yeah, don't need to work quite that big. So if I've got a diameter, I can get the midpoint, which will be the centre of the circle. So the centre of the circle is the mean average of the x and the y coordinates. So minus 6 plus 1 over 2 and 0 plus 4 over 2. So the centre is at minus 5 over 2, 2. And then I just need the radius. So the radius will just be the distance between the centre and either of those points. So the radius is the square root of minus 6 minus 5 over 2 all squared plus 0 minus 2 all squared. So I'm just doing the distance between that point and that point. Okay, so that is going to be, so minus 6 plus 2.5 all squared. So that is the square root of 49 over 4 plus 4. So I'm getting that to be square root of 65 over 4, or root 65 just over 2. But to be honest, I'm not really bothered about that because I want r squared anyway, because my equation of a circle is x minus 5 over 2, or it's a bit of a mess, all squared plus y minus 2 all squared equals r squared, so that will just lose the square root from the 65 over 4. And hopefully that's what they got. Yes, it is. Cool.